Okay. All right, Aiden, here we go. We talked a little bit about this yesterday. In the first problem, it's asking about so-and-so squared both sides and couldn't get it to work out. What did they do wrong? What should have been their first step instead of squaring both sides? When you have two radicals like this that are separated by a plus sign or a minus sign, your first step is to get the radicals on different sides of the equation. So the first thing I would do is either subtract this from both sides, or I would probably, to keep the positives, I would add this to both sides. That should be what you have here. Now, on this next problem, you're to solve this, and you'll notice that the whole side, the expression in the parentheses, which contains the variable, and that's what you're solving for, you've got to get it all by itself. A whole expression is being raised to the 3/2 power. To undo an exponent of 3/2, you have to take both sides and raise it to the reciprocal of 3/2 or 2/3 power. Now if I do that to the left side, I have to do this to the right side as well. Now here you have a power to a power. You would multiply the exponents. 3/2 times 2/3, these are reciprocals. When you multiply reciprocals, you get 1. So this is the same as 2x plus 7 to the first power. Over here, remember, you're taking the 27 and raising it to the 2/3. You could square the 27 and then take the cube root, or you could take the cube root and then square. Remember, this is the index of the root. Index of the root. So like here's scratch work. I could take the cube root of 27, and I'm going to do that first. There's the cube root of 27, and then I'm going to square it, because 27 is a perfect cube. The cube root of 27 is 3, and of course 3 squared is 9. So now I have a simple equation. My variable is where I can get at it. I have it to the first power. I don't need to put a 1 there. I don't need those parentheses. I would just subtract 7. 2x equals 2, divide by 2, and I have x is equal to 1. There's my answer. Now on this equation here, number 6, I'm going to get the variable by itself, so I'm going to undo the stuff around it. But this time, only the x is being raised to that power, not the plus 9. Before, remember how the plus 7 was in the parentheses? The plus 9 is sitting out, so I'm going to deal with it first by subtracting 9 from both sides. And I have x to the 4/3 is equal to 16. Now here's where I do that little rule, that little trick there with the exponent. See, I have kind of an odd exponent there. I have 4/3. What I'm going to do then is I'm going to kind of approach it the same way as I did the other problem by raising it to the reciprocal power. And I'm going to do that to both sides. Now what occurs here, and you have to keep track of, is the fact that the root, it's a 4th root, that's an even number. So you're going to pick up the plus or minus on your answer. Again, power to a power, you multiply, that's just x to the first or x. But over here, I am going to have plus or minus. I either can take the 4th root of 16 and then cube it, or cube 16 and then take the 4th root of it. Since 16 is 2 times 2 times 2 times 2, I'm going to take the 4th root of 16 and then I'm going to cube it. That's what this is equal to. The 4th root of 16 is 2, the principal 4th root of 16 is 2, which cubed is 8. So it's going to be positive 8 or negative 8. You don't need the 1 there. You can go back and plug negative 8 in and see if it works. Negative 8, the cube root of negative 8 is negative 2 to the 4th power is positive 16. Because it's an even power, it's positive. 16 plus 9 is 25. Both of these answers are good. You should list both. Over here, this is a little bit more like this problem. Number 7 is a little bit more like number 6, because the x is the only thing being raised to the power. But I still have stuff to undo around it. I'm going to get rid of the minus 6 first. I'm going to add 6 to both sides. Now again, if these were parentheses around it and the 2/3 were on the outside, kind of like this first example here, or problem number 5 there, then I'd have to approach it differently. But because only the x is being raised to the power, I undo the stuff around that first. So we undo adding or subtracting first. These cancel out. I have 4x to the 2/3 is equal to 16. Now I'll get rid of the 4, that's times it. I'll divide by 4. I have x to the 2/3 is equal to 4. And this is going to be like the last example, in that the x is raised to the 2/3. If I take it and raise it to the reciprocal, notice the denominator is 2. It's an even number. Remember back here with the even number? So I'm going to pick up the plus or minus. x to the 2/3 to the 3/2. A power to a power, you'd multiply the exponents, that'd be 1. This is just x to the first, plus or minus. Now, 4 to the 3/2 means the square root of 4, that's the 2, square root of 4, cubed. So that's 2 cubed, which is 8. So my answer is x equals positive or negative 8. All right, number 8 down here, I'm going to undo. Now this is a little bit more like the first example, except that 5 is on the outside, so I'll get rid of that first. I'm going to divide both sides by 5. And I get the quantity x minus 8 to the 3/4 power is equal to, well, 60 divided by 5 is 12. Now I am going to raise both sides to the reciprocal power. The 3/4 power, the reciprocal of that is 4/3. So that's x minus 8 to the 3/4, all that raised to the 4/3. And then over here, the 12 is raised to the 4/3. Okay? Well, 12 is not a perfect cube. So to take the cube root of 12, I'm going to have an irrational number. Now, if I'm not mistaken, I believe the directions on the problems say something about, well, they don't say anything about a decimal. So I just assume that you are going to grab a calculator here. But this is going to be x minus 8 all to the first power, and it's an odd root. So it's not going to be plus or minus, it's an odd root. So it's going to be 12 to the 4/3. So I'll grab a calculator. Just happen to have one here. I'll take 12 and I'll raise it to the 4/3 power. I don't think you can see that on this here. Let's see, let's move it way up. Can you see that? Probably not. It's probably just a reflection, but maybe you can see that. 12 to the 4/3 power. I used the little caret there, and I hit equals. Let's see if I can keep it steady for you. And I'm going to take it out maybe 2 decimal places, and I get 27.47. If I can get my marker out, I get 27.47. And then I'm going to add 8 to both sides. It's approximate now. I'm going to add 8 to both sides. And I have x is approximately 35.47. I'm adding the 8 to it. Okay? There's that answer. Let's jump up here to problem number 9. I think I'll erase the scratch work here. By the way, I'm hoping that you've tried all these, and I'm also hoping that if you are working on a problem, you don't watch this video first, you try the problem, and then watch that part of the video. And then pause it, and then go to the next one, and so on. Work your way through these. Because if you're just jumping right to seeing my work, you're not going to get as much out of it as having it explained and having tried it first to make sure that you're either doing it right or you can figure out what you did wrong, why you decided to work it a certain way. Don't give up on any of these problems. Try each one. They're all pretty similar. I mean, there's some differences, but they're all having to do with isolating the variable, okay, at least on these problems. Now, these ones that have radicals that are coming up, they're going to be a little bit different. But on this one, I'm going to work it kind of like I did problem 5. I'm going to add 1 to get rid of the minus 1. Okay? And that's going to give me the quantity x plus 9 to the 5/2 is equal to 32. Now I'm going to raise both sides to that reciprocal power. The reciprocal of 5/2 is 2/5. And again, a power to a power, you multiply the exponents, you just get x plus 9 quantity to the first. I'm not going to put to the first. Here, remember, that's the root, that's the power. So this is 32, the 5th root of it squared. The 5th root of 32 squared. Well, the 5th root of 32 is 2, because 2 times 2 times 2 times 2 times 2 is 32. So this is 2 squared, which is 4. Now I'm going to just subtract 9. And I get x equals -5. Now, you may have noticed that in the directions they say check for extraneous roots. I haven't had an example of a problem that has extraneous roots, but with these problems with the radicals, that's a distinct possibility. So we're going to be checking to make sure our answers make sense. So now, let's go to this problem. This one only has one radical, which is good. The fewer radicals, typically the easier the problem. And what I'm going to do is get the radical, the one radical isolated, which it already is. And then because it's a square root, I am going to square both sides. I'm going to square this side, and I'm going to square this side. Now notice I don't square each term, I square the whole binomial, the whole side. So when you square a square root, you just get the radicand, but here you got to do FOIL. X minus 2 times x minus 2, which is x squared minus 4x plus 4 when you do FOIL. It's not x squared plus 4, you have to do all FOIL here when you square this binomial. This is a quadratic equation. I'm going to get two answers. I'm going to have to put it in standard form, so I'm going to subtract x and add 2 to both sides. And I get 0 equals x squared minus 5x plus 6. And I'm going to see if it'll factor. And it does. Looks like an x minus 2 and an x minus 3. So I said x minus 2 equal to 0. I said x minus 3 equal to 0. I get x equals 2. I get x equals 3. Now both of those answers look like pretty good answers. Let's just make sure. Let's start with the 2. If I plug 2 in here, 2 minus 2 is 0. The square root of 0 is 0. 2 minus 2 is 0. 0 equals 0. This one checks out okay. That's a good answer. Plug 3 in. 3 minus 2 is 1. The square root of 1 is 1. 3 minus 2 is 1. 1 equals 1. These are both good answers. You need to check your answers when you're squaring both sides. Okay? You need to check your answers. Now, I didn't have any worries back here. I only had a couple of them that had the plus or minus, and that was because of the even root. I felt pretty comfortable there. I mean, you can check all your equations. Now I'm going to jump up to 14 here. Now in 14, it's cube root equals cube root. There are two radicals, but they're equal to one another. I have one radical isolated on one side, the other one on the other. There are no extra terms. I'm just going to go ahead and get rid of the cube root by cubing both sides. So I have the cube root of x plus 4. That's being raised to the third power. Those are inverse operations. I just get x plus 4. Over here I just get 2x minus 5. And then I have an easy equation. I subtract x. I have 4 equals x minus 5. I add 5. And I get x is equal to 9. Now take the 9, plug it back in. Make sure this is the cube root of 13. 2 times 9 is 18 minus 5. This is the cube root of 13. That's a good answer. Now this one is different than the others. It looks a little like this one, except it's square roots and they're both on the same side. So like the very first example, I want to get one of the radicals all by itself on one side. So I'm going to add the square root of x minus 1 to both sides. I get 6 square roots of x is equal to the square root of x minus 1. Now, kind of like I did here, I am going to square both sides. Now I have two factors here. You know, the 6 isn't inside there. This is the 6 times the square root of x. I have to square both factors. I have just the one expression here that I'm going to square. 6 squared is 36. The square root of x squared is just x. The squaring of the square root, kind of an inverse operation, you can cancel one another out. Here I have x minus 1. I will subtract x from both sides. I have 35x is equal to negative 1. I will divide by 35. And I have x is equal to negative 1/35. Now, here's the deal. If I was to plug this back in to my original problem, I would be putting a negative in there and a negative there. I would get the square roots of negative numbers. That's an imaginary number. That's the theme with the I. So we're not going that route. We're just going to say empty set here and cancel this one out. This is an extraneous root. This looks like it solves this equation, which it does, but it doesn't solve the original, just the transform. That happens a lot when you square both sides. Not when you cube them, necessarily, because you can have negative numbers on the radicals that are cube roots or fifth roots. But when you square both sides, or if you raise both sides to the fourth power, that's when you have to be careful about extraneous solutions. Now, that fills up this board. I'm going to clear this off and we'll do some more problems. Don't go away. Okay, and we're back. Now this is a little bit like the problems we were just doing before. This goes back to the type of problem where the variable is raised to a rational exponent. Here it's 3/4, but only the variable is raised to the 3/4. Like down here, the expression x minus 4 is being raised to the rational exponent. The expression x plus 1 is being raised to the rational exponent. So I'm going to isolate the x first, or the x to the 3/4, by dividing by 4 on both sides. So I have x to the 3/4 is equal to, let's see, that goes in 27 times if I'm not mistaken. Now I'm going to raise both sides to the reciprocal of 3/4, that'd be the 4/3 power. Now notice it's an odd root, so no plus or minus. This would be 27 to the 4/3. This is going to be x to the first. Now 27 to the 4/3 means the cube root of 27 to the 4th. This is 3. The cube root of 27 is 3. 3 times 3 times 3 is 27. 3 to the 4th is 81. 3 times 3 times 3 times 3 is 81. There's my answer. Down here, I want you to be aware of this one. It doesn't happen every single time, but notice that you have a square root, because that's what 1/2 power means. It's a square root, and it's equal to a negative number. Okay, this is a principal square root. You can't get a negative number. There's no solution here. You can see it coming. But if you don't notice that it's coming, if you raise both sides to the reciprocal of 1/2, which is to the second power, you'll get x minus 4, power to a power multiplied, is equal to positive 36. Add 4 to both sides. You'll get x is 40. So if you go back and you check, you plug 40 in here, 40 minus 4 is 36. 36 to the 1/2, that's the square root. The principal square root of 36 is positive 6. If you plug 40 in here, you have 40 minus 4 to the 1/2 equals negative 6. 36 to the 1/2 equals negative 6. This is the square root of 36 equals negative 6. I get 6 equals negative 6, which is false. There is no solution. You can kind of see it coming if you're looking for it, because it's a square root. Now, if it was a cube root, you can have a negative. Okay? Now over here, it's a little bit like this one with the extra step that I have to first divide through by 3. And I have the quantity x plus 1 to the 4/3 is equal to 16. Now, just like I did in the last problem, I take it to the reciprocal power. You have an expression involving the variable raised to a rational exponent. You want to get the variable. You got to undo that rational exponent, so you raise both sides to the reciprocal of this. The reciprocal of 4/3, here I'll use brackets there so you can see it a little bit easier, is the 3/4. I could write it. And I raise it to both sides. Now notice here, this is going to be an even root. It's a 4 in the denominator. I'm going to get a plus or minus here. Technically, you get the absolute value of x plus 1, but I'm going to go ahead and write plus or minus 16 to the 3/4. Up here, that's the 4th root of 16 cubed. That's supposed to be a 4 there. Well, what number times itself times itself times itself is 16? That'd be 2. So this is 2 cubed, which is 8. So I get plus or minus 8. Be careful here, because you want to subtract 1 from both sides. Watch what I do here. I write x equals negative 1 plus or minus 8. Put it first. You put the negative. I know it's a minus 1, but put it as a negative 1 plus or minus 8. That way, negative 1 plus 8 is positive 7. Negative 1 minus 8 is negative 9, and you get your two answers. Now, I'm pretty sure both of those are good answers, but you'd have to take them back to here. Oh, take it back to here and plug 7 in. For example, here 7 plus 1 is 8. The 8 to the 4/3 would be the cube root of 8. 2 to the 4th, 16 times 3 is 48. Then you plug the negative 9 in. Negative 9 plus 1 is negative 8. The cube root of negative 8 is negative 2, but raised to the 4th power is a positive 16. 3 times 16 is 48. Those are both good answers. No extraneous roots there. Up to here, this is a little bit more like what we were doing before I cleared the screen. I want to isolate the radical here, so I'm going to subtract 10. I hope I have this written down right. Kind of tough to read the printout there at times. Now, because this is the cube root, I want to cube both sides. to get the variable by itself. 6 times 6 times 6 is 216. You can plug back in. The cube root of 216 is 6 plus 10, 16. It checks out okay. Good answer. Now this one may remind you of this guy with the negative on the side, but there's an extra bit here. I've got to get rid of the minus 13, so I'm going to add 13 to both sides, and then all of a sudden, I don't have that negative number anymore. I have the fourth root of 2x is equal to a positive 4. That makes sense. You can have an even root that's equal to a positive. So now I'm going to raise both sides to the fourth power, whatever the index is, to the fourth power, and I get 2x because when you raise a fourth root to the fourth power, they're inverses, they undo one another, you just get the radicand 2x. 4 times 4 times 4 times 4 is 256. Divide by 2, 128. There's my answer. Plug back in and check if you don't, if you're not sure or you don't believe me here, you can plug back in. Now this guy looks pretty good with a positive number over here and a square root, but look what happens. Because of the plus 10, you've got to get the radical by itself. I'm going to subtract 10. I get the square root of 6x minus 5 is a negative 7. That's just not going to happen. I showed you this once before. Remember, that means a square root. I have a square root of 6x minus 5 equaling a negative number. That's imaginary. No solution. Empty set. All right, we'll jump up to here. This is a 2/5 times the radical. I'm going to multiply by the reciprocal to undo multiplying by 2/5. I mean, I could divide by 2/5, but that's invert and multiply anyway. So 5 halves times 2/5 times the square root of 10x plus 6, and 5 halves times 12. So that's just 1. I get the square root of 10x plus 6 is equal to 30. Now I'm going to square both sides to get rid of this radical. Again, whenever you square both sides, there's always a possibility, especially if the variable's on both sides. The variable's not on this side, but if I square both sides, now 30 squared is a pretty good sized number, considering most of these problems. You square the square root, you get the radicand. Over here I get 900. I'm going to subtract 6. I'm running out of space here, and 894, and I'm going to divide by 10. And I get x is 89.4, and there's my answer. Now, unless I wrote the problem down wrong, again, sometimes it's hard to read. Now, this is like a problem that we did a little bit ago, where we have the variable on both sides, and I am going to have to square both sides. So beware of the extraneous solution. So this radical is all by itself on one side, perfect. I'm going to square both sides. Now remember, it's a binomial, you have to square the binomial. This is just going to be 8x plus 1 when you square the square root. They undo one another. But here I've got to do FOIL, and I'll go ahead and multiply it out. You get x squared plus 4x plus 4. X plus 2 times x plus 2. Let's subtract 8x and subtract 1 from both sides to get it into standard form. And I get 0 equals x squared minus 4x plus 3. Well, I believe that's going to factor. That's going to be x minus 3 times x minus 1. And I'm going to set both of these equal to 0. And I get x is equal to 3, and I get x is equal to 1. So in this case, I'm going to get two answers. I think they're both good answers, but I won't know until I check. Hopefully this marker is a little darker here. I'm going to go back to here and I'm going to plug 3 in. 8 times 3, 24 plus 1 is 25. This is the square root of 25 is 5. 3 plus 1, 3 plus 2 is 5. 5 equals 5. Good answer. Plug 1 in. 8 times 1 plus 1, that's the square root of 9, which is 3. 1 plus 2 is 3. These are both good answers. Okay, up to here I have radicals on the same side, two different ones. I'm going to subtract the fourth root of either one. I'll just do this last one here from both sides. Now I get the fourth root of 2x is equal to the opposite of the fourth root of x plus 3. I'm real suspect about this problem because I know this has got to be positive, and I know that this has got to be positive. I got a positive equal to the opposite of a positive. I don't think I'm getting an answer here because it's an even root. If it's an odd root, no problem. I'm going to raise both sides to the fourth power. and I get the fourth root to the fourth power, I get 2x equals negative times negative times negative times negative is positive, x plus 3. Well, it looks like I'm getting an answer. Subtract x, it looks like I get x equals 3. Let's check. This would be the fourth root of 6 plus the fourth root of 6 equals 0. Well, that doesn't equal 0. If it was a minus, it would equal 0. Bad answer. Extraneous. No solution. This one's kind of like it, but if I add 2 square roots of x to both sides to get the radicals, whoop, sneak a 2 in there, get the radicals on separate sides, isolate the radical, I get the radical here, I get the square root of 2x plus 10 is equal to 2 times the square root of x. It's a square root, square both sides. So this side gets squared, this side gets squared. I get 2x plus 10 when you square a square root. Here, the 2 gets squared, 4, the square root of x gets squared, is x. Subtract 2x from both sides, isolate that variable. 10 equals 2x, divide by 2, and I get x is equal to 5. Let's see if that's a good answer. Plug 5 in here. 2 times 5 is 10 plus 10. My check here, that would be the square root of 20 minus 2 times the square root of 5. Does that equal 0? Well, 20 is 4 times 5, so this radical simplifies. The square root of 4 is 2. This is 2 square roots of 5 minus 2 square roots of 5. Yep, that's a good answer. You just have to check your work. It would have been nice if it come out to be integers, but you had to simplify the radical to show that it does indeed check. All right? That's a lot of good problems in there. There's a lot of, but you just need to practice these. I mean, if you want to practice some of the problems that weren't assigned and then ask me about them, I can work them out and you can check your work with that as well. Remember, you can call me and get help if you have questions or if you don't understand these explanations. Now, the last 2 problems have to do with applications, or kind of like story problems. So I'm just going to go ahead and clear this part out here real fast, and then I'm going to see if I can help you with these problems as well. Oh, maybe I'll clear this out too. Uh-oh, not cleaning very nice. Got a feeling I'm going to have to get some wet paper towels here to get this thing cleaned up a little bit. All right, let's look at the last couple of problems here. It says, and I can't read this very well because you can see my copy is not very good, but it says something about the length in inches of nails of a standard nail can be modeled by, now I have this part I think written down correctly. It looks like it's the length of the nail, and get the marker out, L is equal to 54d to the 3/2, where d I believe is that the diameter? It's the diameter of the nail, and L is the length of the nail. You can't have really long skinny nails because they'll bend as soon as you try to tap them in with a hammer. So it says find the diameter if the length is given to be 3 inches. So the length is 3 inches. I'll put a 3 here, and I'm going to solve for d, the diameter. So it's kind of like the other problems. It's just that you have to create the problem by plugging in. I'm going to divide both sides by 54, and I get 3 over 54, which is 1/18, is equal to d to the 3/2. I'm going to raise both sides to the 2/3 power. Oh, holy smokes. Is that a 3 or a 2? If it's a 2, it comes out even. Maybe I got the problem wrong. No, it says 3 inches. And I'm pretty sure that says 54. Doggone. Well, we're just dealing with it. So I hope I have these numbers right. If I have the numbers wrong, it's going to work similar, but you're going to get different values. But I'm going to raise both sides to the 2/3 power. The reciprocal of 3/2. So I have this expression. This is just d. That's where I'm trying to get anyway. But I have to take 1/18 and divide it by 2/3. Now, that's the cube root of 1/18 squared. So this can simplify a little bit. This is the cube root of 1 over the cube root of 18 squared. I'm not getting far in a hurry here. I'm going to probably grab a calculator. Does it say anything about rounding here? No, it just says find the circumference then. Well, the cube root of 1, of course, is 1. This doesn't simplify. Oh my goodness, what would I have to multiply? I'd have to multiply top and bottom by 324. Now, we're grabbing a calculator. So what I have to do is grab my calculator here. I'm going to take 1/18, parenthesis 1 divided by 18, raised to the, where's my caret, raised to the 2/3 power. Okay, let's see if you can see that. See below? 1/18 raised to the 2/3 power, and I get 0.1456, and this is approximately the diameter. So the diameter is approximately 0.1456, and this is in inches. So make sure you answer it in a short sentence, because it's a story problem. The last example, also they give you the equation to use, and probably going to have to grab this calculator again. I wrote the equation down to look like this. Now again, my copy is so hard to read, I could have this incorrect, and if I do, and you have a question, I'll be happy to go over it. It looks like 273 over 100, where this is, C is the circumference of a dinosaur's femur, and M is the mass of the dinosaur, and that's in kilograms. They said find the diameter, or the circumference of the femur, if the mass is 4,500 kilograms. So 4,500 here equals, now, 1.6 times 10 to the negative 4 is the same thing as 0.00016, negative 4, 1, 2, 3, 4, times C2 then, of course 273 divided by 100 is 2.73. Now I may want to just leave it as 273 over 100, and you'll see why in a second, but I am going to divide both sides here by 0.00016, 0.00016. I hope I got these numbers right, because this is going to be pretty small, pretty big number over here. So I'm going to take 4,500, and I'm going to divide it by 0.00016, and I get a good size, healthy number here. 28,125,000 is equal to C to the, and again, you may want to leave this, just for the convenience of it, you may want to leave it as a fraction, because now you can see you're going to have to raise both sides to the reciprocal power. If you don't mind writing that as 1 over 2.73. So both sides to the reciprocal power, and this becomes C, the circumference of this femur, and I think this is in millimeters or something, which is a pretty small amount. So now I raised, remember that number I had? I'm going to raise it to the 100 divided by 273 power. Can you see it? And I get 535 point, let's say 31. And again, it's really hard for me to read, but I believe this is millimeters. So the circumference of the femur, what was it? It was a, I don't know, it was a dinosaur. The femur of the dinosaur dinosaur, oh man, sorry, is 535.31 millimeters. Don't forget your abbreviation. Now, if we slide that decimal point 3 places to the right, that would be about a half of a meter. Well, that's about, I don't know, that seems a little small. Maybe their femurs weren't as big as I thought. Hopefully I got the numbers right, but there's the answer. All right. Remember, give me a call if you have any questions. Hope this helps. Take care, boy.